It's December, and the sky feels unhurried. A small visitor crosses the dark like a lantern carried far away. I'm here at your bedside voice, steady and low, to keep you company while it drifts. If you can, put your phone on Do Not Disturb. Maybe slip on headphones so the world narrows and softens. Tonight, I'll be your sleepy scientist, guiding you through a calm tour of an interstellar traveller. What we've seen, what those sights may mean, and where gentle curiosity is enough. Before we wander, a tiny invitation. Follow the Sleepy Science playlist so these long, quiet journeys are easy to find when you need rest. No rush, no urgency, just a thread to pull when the night is long. We'll keep the pace kind. First, a postcard of arrival. Then, the slow turn of the body, how light flickers when a world rotates. After that, the ink fine lines that seem to reach away, and the colours that whisper what's in the glow. We'll trace the path through our planetary plane as if across a map at dusk. We'll talk about small pushes that comets feel, and why models breathe and change. We'll hold a few hypotheses with open hands. We'll end with a quiet ledger of only what's solid. Nothing here asks you to decide. You don't need conclusions to fall asleep. You just need a calm voice and a sky that behaves like a lullaby. I'll carry the detail. You can set it down whenever your breathing lengthens. Settle in. The lights are low. The traveller is already here, moving slowly across the page of night. When you're ready, we'll begin, softly and without hurry. It is December, just past midnight, and the room is more hushed than dark. A traveller from elsewhere crosses the quiet above us, unhurried as a ship that trusts the tide. I set a postcard on the bedside table, a pale smudge found by survey eyes in the southern winter, declared interstellar soon after, and added to the short ledger of visitors that did not form here. Interstellar means the path it follows will not close. Not an oval, not a loop. A long, bending line that kisses the sun and keeps going. Think of a snowflake drifting into a warm kitchen, circling the stove once, then slipping out the far door. That's the scale of it. The comet came in hot and backward compared with the usual traffic, then threaded the thin plane where our planets live, and in doing so gave our instruments a steady look. We first glimpsed its presence in high, patient frames. Survey telescopes noticed a point that moved in a way only a visitor would. The classification followed quickly, not bound, not ours. Soon after, space-based optics set their gaze and carved a clean silhouette from the glare. There it was, wearing a soft cocoon of dust, a little teardrop glow around something tougher within. Even from far away, the shape said comet more than asteroid. Ice, stirred by sunlight, dust lifted, the classic breath of a body waking as it warms. Let's pause the star charts for a minute and make the room gentler. The fan traces a pale oval on the ceiling. A street lamp finds the edge of a curtain and leaves a faint stripe on the wall. Somewhere a refrigerator clicks and settles. Breathe with those sounds for a handful of easy counts. If your shoulders remember the day, let them lower a little. The visitor will not rush us. As it rounded the sun in late autumn and began the long outward leg, the viewing geometry improved for Earth. That is simply the ballet of angles. For a while, the comet hid in glare and in distance. Then the line between us bent just enough. During this season, professional observatories and careful amateurs alike are sharing a patient watch. Big mirrors chase spectra and colour. Small ones collect time and brightness changes. Each image is a bead, and the thread grows long and useful. What do we call that faint glow? Coma. A hushed atmosphere of gas and dust that surrounds the solid heart when sunlight warms frozen material near the surface. Sometimes a tail draws out like breath on a cold morning. Sometimes geometry hides it, and we see more halo than plume. Either way, the physics is steady and kind. Sunlight shakes molecules loose. The tiniest grains ride along. Larger ones fall back or drift close by. In the glow, color can tell us something about the mix, and the way brightness wavers can hint at a slow turn within. You and I will come to that turn with care in the next chapter. For now, it is enough to picture a body that spins slowly, as most do. Not a roulette wheel, not a blur, just a measured rotation that makes the light on its face breathe in and out over hours. From those small changes, patient teams extract rhythm. From rhythm, they infer shape, stability, and surface patchwork. Nothing dramatic, only the kindly mechanics of a natural object warmed by a nearby star. There's comfort in the ordinariness of a wanderer that behaves like a comet, even when it comes from a garden that is not our own. The night is good at reminding us that the strange can also be normal somewhere else. So we keep a ledger without verdicts, found in early summer, confirmed as interstellar soon after, imaged in crisp detail from orbit above our atmosphere, swung by the sun in late autumn, and now sets a course outward, passing Earth at a safe and roomy distance in mid-December, still far enough to be only a dot in our best glass. If you like, picture a harbour after midnight. The lighthouse sweeps a slow arc. A ship crosses the mouth of the bay, its deck lights dim, its wake soft. No horns, no hurry, just passage. That is our traveller now, leaving us brighter for watching and calmer for turning the watching into something gentle to fall asleep to. Let that be enough for this first card on the table. When you're ready, we'll tip the postcard and see the slow turn glint. We'll listen for the faint pulse that lies inside the light. Nothing urgent, only a measured tick, like a clock on a quiet shelf. For tonight, the harbour lights are steady, and our visitor glides. What does a quiet spin sound like to the eye? If you stare long enough at a small smudge in the dark, can you hear the rhythm hiding in its light? Astronomers listen with brightness. A comet turns, and as different faces roll into the sun, the glow grows and fades in a gentle wave. Plot that wave against time, line up many nights, and a pattern begins to repeat like a clock that prefers patience. That is a light curve, and from its repeating crest and valley, we find how long the body takes to complete one turn. For this traveller, teams working across weeks folded their measurements and found a same again beat. About 16 hours for a full rotation, the kind of number that appears not as a shout, but as a consensus hum. There is a craft to this listening. Each night's data carries weather, seeing, and the soft drift of instruments. You correct gently, you subtract the sky, you keep only the comet's pulse. You try different trial periods, you stack the nights, and you ask which choice makes all those waves sit neatly atop each other. When they do, the noise falls away, and the signal looks simple, as if someone brushed the curve smooth with a fingertip. That is the feeling observers describe when a period solution locks. 16 hours is unhurried. It means that if you could hover near the equator of the nucleus, you would watch a slow sunrise arrive, not in minutes, but in many. A shadow on a ridge would slide like a careful hand across a table. Day and night would be measured in long, even lines, not the whip and blur of a fast spinning pebble. For listeners in bed, that matters because gradual rhythms are soothing. The sky, in this case, is keeping time with how a resting body prefers to breathe. There is also comfort in what a slow turn implies. Loose mixtures of ice and rock tend to prefer modest spins. Turn too quickly, and the outward tug overcomes the little gravity they have, and pieces wander away. Turn slowly, and the grains hold together. The weak seams stay closed, and the whole behaves like one object under a warm lamp. Our visitor's period sits in that calm range, not close to any edge, not a stunt, not a race, just a measured tick. Lightcurves tell us more than speed. The size of the brightness swing across a rotation hints at shape and surface. A small swing suggests either a roundish body or a surface where dark and bright patches average out. A larger swing whispers of elongation or of striking contrast. Perhaps a darker hemisphere versus a lighter one, or a single fresh patch that flashes like a pale stone among darker soil. For 3-eye atlas, the changes over each cycle are there and readable without being theatrical, the kind a notebook favors when it prefers numbers that lean toward ordinary. Because the period emerges from light, not from a physical stopwatch held to the rock, there is room for caution. Dust in the coma can brighten or dim with viewing angle. Trails of grains shed during earlier days can overlap the nucleus in our line of sight and nudge the curve. Observers handle this by watching many nights from many telescopes, at slightly different angles and colours, and then asking if the beat remains. Here it does. Within tight uncertainty, the 16-hour rhythm keeps time across instruments and locations, which is the kind of agreement that helps people sleep well after a long reduction session. Let's step off the chalkboard and walk into an old clockmaker's room. Oak bench, soft lamp. A brass wheel turns on a spindle, not fast enough to sing, just fast enough that you see the same mark come around a few times a day. The hands do not jerk. The escapement clicks with a sound that is more felt than heard. That's the picture I keep by the bed when I think of this comet's rotation. A measured tick, neither urgent nor bored, giving everything else in the system a gentle reference to lean against. From that reference, other questions become easier to phrase. If a comet is turning, materials warmed by sunlight can vent from specific regions when those regions come into day. Over many hours, that venting may wax and wane with the same period that the light curve reveals. Sometimes images catch the effect, and streaks appear offset from the nucleus, following the geometry of motion and the pressure of sunlight and the wind of charged particles that thread through space. In early November, several observers reported long, narrow features in stacked frames, straight, ink-fine lines that reach far from the head. We will sit with those pictures in a later chapter and keep the vocabulary gentle. For now, the important thing is to build our quiet base. The comet turns once about every 16 hours. That turn is steady enough that different teams, using different nights, arrive at the same rhythm. The pace is leisurely, consistent with something held together by small gravity and the cohesion of frozen materials. If you are making mental maps at the edge of sleep, you can sketch one arrow labeled spin and let it circle slowly, a reminder that beneath the glow there is a wheel. There are always small questions at the edges. Does the period drift a little as sunlight nudges the surface over weeks? Do vents add a whisper of talk that subtly hastens or slows the turn? Are we seeing the true rotation or a harmonic created by alternating bright and dim patches? The way to answer is through time, and time is what we have as the object recedes. More nights, more folds, more agreement or gentle adjustment. That is the kind of science that pairs well with bedtime, because it values patience over spectacle. And so we keep the benchlight low and let the wheel glide. The second hand is a comet's brightness. The hour hand is its long path through our plane. We watch without leaning in, content to know that the motion is there and that it is soft. When we speak of lines that seem not to curve, we will return to this room and set their questions next to the turning wheel. If they fit together, they will do so without noise. If they do not, we will know that too, gently. For now, let the colours of the charts wash into one another, like inks mingling on damp paper, and dissolve into something simple and calm. Imagine a single still frame held to the light. The room is dim. Your breath settles. Outside, the night keeps its own steady hush. In the image, the stars are pinpoints. The traveller sits just off-centre, surrounded by a faint, even glow. And from that glow, 2 or 3 lines slip outward, ink-fine, almost ruler straight, as if someone touched a brush to the paper, and then lifted it carefully away. Let's stay with the picture, rather than the puzzle. A soft green trace floats near the nucleus, the kind that sometimes rides with comets when certain molecules are excited by sunlight. The background is a calm scatter of white, a few galaxies smudged like thumbprints, and, across the field, a line that might be a jet, or a processing artifact wiped clean by careful hands, or a real structure drawn thin by distance. The frame is stacked from many exposures, so the signal rises above the night. Between each exposure, the comet crept a little. The stars were shifted back to their places, the faintest features added up like whispers agreeing. For a minute or so, do nothing but watch. A heater ticks. The window breathes a faint thread of cooler air. You trace the lines with your gaze, and when they leave the core, they do not immediately broaden. They keep to their course like filaments floating in a slow current. Maybe they bend gently. Maybe they hide their curves over distances too large for a single frame to show. Either way, the image is quiet. The story it tells is patient. Now step back half a pace. Other nights show similar scenes. Early and mid-November offered modest treasures. Observers in different countries loaded their cameras with long exposure stacks and found that the head was not a mere blur. Lines appeared. One of them seemed to aim sunward, a thing comets can sometimes show when geometry and dust sizes conspire. A so-called anti-tail that is not matter flowing toward the sun, but particles arranged in a way that our angle of view turns into a needle pointing against intuition. Another line leaned away, narrow for astonishing distance, the way ink can travel along water. Without immediately feathering, images like these invite vocabulary, and vocabulary invites conclusions. We will take our time. Jet is the common word for the thin streams of gas and dust that lift from vents when sunlight warms fresh patches on a rotating surface. In raw frames, jets often look like gentle fans near the head, and then broaden or arc under pressure from light and the solar wind. But stacking, filtering, and the angle of our view can sharpen the impression. When you align on the moving comet, the stable background is intentionally smeared. When you align on the stars, the comet smears. Either choice changes the look of filaments at the edge of detectability. Good practice shows both, compares both, and reports with care. There is another layer to the eyesight of these pictures. The tail of ions, which are charged particles, often runs very straight, trained by magnetic fields in the solar wind. The dust tail is usually wider and more curved, its grains pushed and sorted by radiation pressure according to size. An antitail can appear when Earth crosses the plane of the comet's orbit. The dust sheet that normally looks like a broad panel suddenly flattens into a needle from our vantage. This is geometry's kind trick, not a reversal of physics. Recognizing which line is which takes time, color, and coordinated views. If you hold one November image in your thoughts and then lay another beside it, the lines are not always the same. One will show two narrow rays, another will show a principal line and a fainter companion. A third will show a subtler bloom, more like breath on glass than ink on water. Nightly weather changes the depth you can reach. Exposure time changes it further. Even modest differences in the filter shift the balance between gas glow and reflected dust. That is why compilations are useful. A gallery of frames taken from different latitudes and longitudes becomes a slow flipbook where durable features remain and the fragile ones fall away. Keep the bedside metaphor close. You stand at a window with drizzle on the pane. A streetlight beyond is doubled into lines by the streaks of water. If you lean an inch left, the lines change. Lean an inch right, they change again. What remains from angle to angle is not the exact length or thickness of each streak, but their shared direction, their persistence across small shifts, their reluctance to vanish when the view is adjusted. That is how astronomers grow confident that a feature is not a trick of processing. Some frames show the comet's head as a soft almond shape, with the thinnest of needles touching one tip. Others show the head more circular, and the line continues from it as if drawn with a compass edge. Where the line stays narrow over many hundreds of thousands of kilometers in the assembled mosaics, the mind's first instinct is to ask how it keeps that discipline. Natural answers exist and deserve priority. Charged particles guided by fields, grain sizes that sort themselves into tidy shelves, viewing angles that turn fans into strands, and the self-selection of images where faint, straight things are easier to notice and share than faint, diffuse ones. Still, the correct next step is always the same. Observe more, compare across methods, fold the nights into patterns that can be tested. A gentle caution belongs here. When features are near the threshold of detection, small choices in reduction matter. Subtract too much background, and you sand away the very whispers you hope to keep. Subtract too little, and soft noise knits itself into ghosts. Stretch the contrast a bit differently, and a curve can masquerade as a line. That is why experienced image makers publish both the aesthetic composite and the planar stacks, and why they share their recipes openly, so others can repeat the work and see if the same lines appear. At the telescope scale, some observers reported that the anti-tail persisted night after night through mid-month. That is encouraging if you are trying to tell geometry from mirage. Others found that a lateral feature grew as the phase angle changed, suggesting particle sizes with enough heft to resist immediate dispersion. None of that requires drama. It asks for patience, a virtue that pairs well with sleep. Let the room fade a notch. The heater settles. The image in your mind's hand is still the first postcard. A core, a soft green trace, a line as fine as a thread laid on water. Whether that line owes more to ions trained like a tightrope, or to dust, organized by our viewing angle, we will keep both on the table. Later, when we speak about spectra and color, and the ways gas differs from dust, the picture will sharpen another step. For now, the lantern dims, and the frame returns to the dark, leaving only the memory of quiet lines that prefer not to rush. Let's set the scene like a small lab after hours, a clean bench, a prism on felt, a notebook open to a calm page. The kettle clicks off, and the room breathes in a slow, even way. When we talk about what light reveals, we mean this kind of listening. Quiet, careful, kind to the eyes. Some comets carry a soft green veil. Under sunlight, a simple molecule, diatomic carbon, two carbons clasped together, can glow emerald as its electrons are nudged and fall back again, releasing light in narrow bands our cameras love. Earlier this month, large glass under a steady sky caught 3I Atlas with that familiar wash, a green that looks almost painted on the coma. In one frame, the tail seemed to vanish, as if the comet had forgotten one of its lines. It had not. Geometry can turn a wide sheet of dust and gas into a head-on glare, hiding breadth behind brightness. Tilt the view, and the line returns. In colour, though, the glow stayed, loyal, the kind of green we expect when sunlight plays this molecular song. Colour in comet lore is not drama. It is a thermometer and a fingerprint in one. Green near the head can mean C2 singing in ultraviolet-triggered light. Farther down a tail, if the dust takes over the scattering, things turn more sun-yellow or white. Filters help us sort the chorus. A wide filter listens to everything at once and tells us brighter here, dimmer there. A narrow filter listens only to one note and tells us this molecule is present and lively. Turn 2 or 3 of these filters into alternating frames, and you can watch the mix shift with time and angle. Now, from light you see, to light you can't. Radio telescopes, big ears in quiet places, can hear molecules humming that the eye will never notice. Recently, an array in South Africa listened for hydroxyl, the fragment called OH, which is born when sunlight breaks water apart. In the radio, OH has telltale lines near 1665 and 1667 MHz. Detect those, and you've heard the breath of water, not as steam, not as frost, but as the echo of molecules with an unbalanced charge singing through space. Astronomers reported exactly that kind of detection from 3I Atlas, an absorption imprint against the background, aligned with the comet's motion. It is a small, sturdy sign that water is present in the mix, doing what water does when warmed by a star. If you sketch the picture on your notebook, you begin with the Hubble frame from mid-year, a teardrop coma, stars streaked because the telescope followed the traveller. Add the later ground-based portraits, the green veil near the head, the sometimes narrow line from the nucleus, the occasional head-on view that hides the spread of dust like fog hiding the length of a beam. Now annotate the margin with radio notes, 2 quiet tick marks at those OH lines. Each of these is a different sense organ, eye, filter, ear, describing the same body from a different angle of physics. You might ask whether colour shifts with the spin we traced in the last chapter. Sometimes, yes, but gently. If one patch is fresher or cleaner ice, it may release a little more gas when it rotates into day, and a narrowband filter will measure a small rise in that species. If another patch is dustier or darker, a broadband image might brighten or dim a touch as that face turns. Stack many cycles under different filters, and the pattern, if present, folds into the same 16-hour pulse. When it does, it reassures. The light curve and the colours agree that there is a wheel beneath the glow. Spectroscopy, the art of spreading light into a barcode, adds comfort in other ways. When you split the coma's light, you see gas lines that carry their own widths and shapes. Sometimes you catch motion, a slight shift that says this flow leans toward or away. Sometimes you see that dust, which does not glow on its own, simply scatters sunlight and keeps the sun's spectrum, but softened, more like chalk than ink. Gas and dust behave differently across wavelengths, and that difference lets you untangle what a pretty image might otherwise tangle. It helps to keep the humble possibilities close at hand. A greenhead does not mean strange. It usually means C2, a very old story in comet science. Oh, at radio frequencies does not mean message. It is water broken by sunlight, as ordinary in comet comas as frost on grass at first light. An apparently missing tail can be a face-on sheet. A narrow line can be an ion stream trained by the solar wind, or a dust plane made needle-thin by viewpoint. The work is to test each simple idea with more colour, more time, more angles. I like to imagine the bench again, the prism, the kettle, the felt. A spectrum runs blade-thin across black paper, green bright near the middle. A pencil labels a few known notes, C2 here, CN over there, OH in the radio, written as a reminder in the margin. You place a small metronome near the prism, and it ticks the 16-hour rhythm in your mind's ear, too slow to hear as sound, perfect to hold as a number. At this pace, you do not chase. You collect. You compare. You set 2 nights side by side and ask if the colours rhyme. If they do, you smile. If they don't, you smile anyway and check again when the weather clears. And then, gently, we set down the tools. The lights on the bench dim to a shoreline hush, as if waves were smoothing small stones just beyond the door. The comet goes on singing to itself in gas and dust, and we listen without leaning forward. Green where physics paints it. Oh, where sunlight trims water. A rotation that keeps the time of a body that is comfortable in its own turn. Tomorrow, we can trace the path through our plane. Tonight, let the spectrum roll back into white and let the room go quiet. Picture an old map room at dusk, cabinets of drawers, a long table of wood with a soft cloth laid over it. I unroll a chart with the steadiness you bring to bedtime, and there, drawn as a pale band, lies the ecliptic, the grand guideline of our neighbourhood. It is simply the plane of Earth's path around the Sun, and because the planets formed from a flattened disk long ago, most of them keep to that same page of space. Mercury wobbles a little, Pluto wanders a lot, but the family resemblance holds. From our vantage, their motions trace a belt across the sky. When something new appears near that belt, the eyes of our instruments are already there, watching the traffic where it is densest and where experience says discovery often waits. Onto that band, draw a fine thread for our visitor. It does not flow with the usual traffic. It runs retrograde, backward relative to the planets, and still skims close to the plane where they move. That combination is part of why we noticed it so quickly. It crossed the busiest lane at a crisp angle and kept its distance from the deep polar sky that survey cameras patrol less often. Retrograde here is not a verdict, it's a direction. Think of a leaf on a stream turning against the current near the surface while still gliding along the water's broad sheet. From Earth, that makes for useful geometry. Nights, when the comet sits at convenient angles to both our atmosphere and our instruments. Nights, when its path is neither too steep nor too shallow to follow. On this chart, I mark late October, where the arc dips nearest the sun, perihelion, the turning point from in toward out. For a while, the glare made the traveller hard to study. Sunlight in the line of sight washes fine detail away like surf flattening sand. Then the angles opened, and as November wore on, more frames gathered the coma, the colours, the pencil-thin features that images sometimes revealed. I add another mark at mid-December, when the distance to Earth reaches its minimum, still safely far, still a dot to our biggest mirrors, yet close enough for better spectra, steadier light curves, and many more eyes to join the quiet watch. This is what a good sky map does at bedtime. It trades drama for placement, fear for context, and tells you where to rest your gaze. Let the chart stay open while the room slows. The window cools under your fingertips. A hallway clock moves without insistence. Far off, a motor hums and fades like a line drawn and then lifted. You can hear paper breathe when you smooth it with your palm. The lamp isn't bright, it's kind. For half a minute, follow the thread with your eyes the way a tide line curls along sand. You're not trying to memorize numbers. You're letting direction become familiar, in the way a quiet street becomes familiar when you walk it at night. The map holds still. Your breathing matches its patience. A path near the ecliptic has a practical effect. It puts the comet where most survey programs spend their time. Selection effects, the statisticians call it. We point more glass where interest in things are likely, and so we find more things there, and the pattern reinforces itself. Interstellar visitors can arrive from anywhere at all. A few will slice high above or below the planetary plane and escape our attention, except in the luckiest circumstances. The ones that slice through the belt, we work hardest, will naturally be the ones we see in detail. That bias doesn't make this traveller less intriguing. It makes our sampling easier to understand. When a discovery starts to feel improbable, simply because it met our eyes, this is the gentle cure. We remember where we were looking. From the map to the motion. When you plot nightly positions, you get not a perfect curve, but a tidy scatter along it. A handful of points each with small uncertainties. Models fit those points and update as fresh ones arrive. The fit improves, then breathes a little as the physics we include, gravity first, small outgassing nudges sometimes, gets tuned. This is ordinary. It is how comets have been followed for decades. A path that threads the ecliptic doesn't imply a plan or a tour. It implies that our instruments, designed to watch that belt, will give us the gift of more data. And data makes bedtime kinder because it turns big unknowns into smaller, named questions. If you like metaphors, keep the cartography close. The ecliptic is the map's ruled baseline, the straight edge that lets you draw clean bearings. Our visitor is a pencil stroke taken at a slant across that baseline, fine enough that you can trace it with one breath. Perihelion is the point your pencil pressed a little harder, leaving a darker note. Closest approach to Earth is a soft pencil dot at the margin, important for our observation plan, unimportant for our safety. This way of seeing tames the impulse to read intent where geometry is enough. The sky has 1,000 stories. The map helps you choose the one that lets you rest. Sometimes, in the swirl of headlines, you'll hear the word maneuver used casually when predictions and positions drift. But a map made of patient points tells a quieter tale. Non-gravitational terms exist because ice and dust do what warmed materials do. Tiny thrusts add up and nudge the curve. Survey schedules, weather, and calibration can all shift a nightly position by a breath's width. When you fold those breaths together, the line smooths. If a day comes when the curve truly kinks in a way the simple forces cannot explain, the community will not whisper, it will measure. Until then, the kindest thing we can do is keep plotting dots and letting the thread reveal itself through time. I'll leave the chart unrolled for you a little longer. The band of the ecliptic looks like a quiet road across the page. Our visitor's stroke crosses, then tilts away toward the deep, where the room is already headed. If you stand at the night window and look out, you'll see only the nearest reflections, the room, your breath, the faint shape of your shoulder in the glass. And beyond that, the same sky this map describes, a ledger of motions written slowly. Close your eyes, and the thread will still be there when you open them again, thus fine and unhurried, exactly where we left it. Tonight, let's unpack one small phrase that shows up in observatory notes and orbit pages, then set it gently back where we found it. The phrase is non-gravitational acceleration. It sounds stern. In practice, it's quiet, like a breath you only notice when the room is still. Gravity writes the main sentence of a comet's path. The sun pulls, the comet falls and swings and leaves. But comets are not stones. They warm, they vent, and the gas that lifts away pushes back on the nucleus with a nudge so slight you'd miss it in a single step and only see it when many steps are added together. Astronomers measure where the comet appears night after night against background stars. If a purely gravitational curve can't make those points line up cleanly, they add a very small, very ordinary extra, a model for the outward breath. Think of a balance scale on a countertop. One pan is gravity, heavy and consistent. The other pan is a tiny spoonful that comes and goes with sunlight. Gas flow from warmed patches, a sprinkle of dust that tags along. Add the spoonful and the beam tilts a hair. Take it away and the beam returns. That tilt is what the equations label as a non-gravitational term. It doesn't replace gravity. It rounds the numbers to match the comet we actually see, rather than the stone we imagined first. In the orbit fitter's toolbox, there are 3 gentle levers. Not formulas you need to memorize, just directions that make sense at the bedside. One points roughly toward or away from the sun. One lies along the direction of travel. One leans out of the orbital plane. With those three, you can whisper, a touch more sunward here, or a breath a long track there, and the predicted path settles closer to the nightly dots that telescopes collect. Because venting tends to strengthen near the sun and weaken far away, these levers are tied to distance. Closer, the spoonful weighs more. Farther, it weighs less. The result is a curve that breathes. As new positions arrive, the solution updates. Ephemeris pages publish revised elements. Observers download a fresh set, point accurately again, and the story proceeds. Nothing dramatic. It is the bedtime version of feedback. Watch, nudge, watch again. A comet on a path near the ecliptic, watched by many eyes in a short season, will earn frequent refinement simply because there is so much data to honor. Why can those small nudges be hard to pin down on the first pass? Because comets are patchwork worlds. One face might be crusted and quiet. Another may hide fresh ice under a thin skin that cracks at local noon. Vents light up and fade with rotation. The coma, which is the fuzzy atmosphere around the nucleus, scatters sunlight and can pull a measurement center a whisper off the solid heart if you're not careful with the math. Add the drift of thin cirrus, a gust of wind across a mountaintop dome, or the taste of moonlight left in the sky after a bright phase, and the early dots carry their own tiny biases. Over weeks, those soften as teams compare results from different instruments and nights. There is a rhythm to outgassing itself. Gas doesn't leap from every surface equally the moment sunlight arrives. It often lags. A little heat must walk down into the material. A little later, the vapor finds a path back to space. That lag means the spoonful on our balance pan isn't perfectly in step with distance alone. It can be slightly stronger after closest approach than before, or stronger in one season than another, depending on which side of the comet's face the active regions favor. Good models include that asymmetry, the way a clockmaker sets a pendulum's arc, not to be flashy, only to keep time with reality. All of this lives far below the level of drama. A non-gravitational term is not a siren. It's a notation that says, this is a comet, not a cannonball. For many comets, these small pushes are expected and welcome. They tell us gas is present. They tell us the nucleus is awake. A strong term invites more care in assigning uncertainties. A weak one might be hard to separate from measurement noise until the data set grows. Either way, the right response is patience. Take more points, widen the color range, and allow the fit to settle, as a quilt settles when you smooth it with both hands. You may have seen phrases like, the orbit was updated again today, or residuals improved with a small outgassing force. Residuals are simply the differences between where the curve says the comet should be and where it was seen. When those differences show patterns, consistently a little sunward, consistently a little along track, adding the tiny breath force makes the pattern fade. If the pattern refuses to fade, the community checks for other causes. Field distortion not fully corrected, star catalogues with minute offsets, an extraction method that weighted the coma too much and the nucleus too little. Most of the time, tidy housekeeping fixes the mismatch. Because we're speaking softly tonight, let's walk the pendulum once more. The sun's pull is the anchor weight. The outgassing is a slow, changing fingertip on the bob. Near perihelion, the fingertip presses a touch more. Far away, it barely grazes the metal. The swing does not lurch. It shifts by millimeters over hours, by centimeters over weeks, and when you stand back across the room, those centimeters add up to a path that's the same kind of curve you started with, only more honest about the body's breadth. There is another small kindness in these terms. By fitting the extra push, we learn about material we cannot see directly. A sunward lean hints at where active areas sit, and a long-track nudge gestures toward how much gas leaves as the day proceeds. A gentle tilt out of plane can suggest that vents prefer one latitude on the nucleus. None of these inferences needs hard edges. They grow stronger when independent teams agree, when spectroscopy finds matching changes in line strengths, and when images show surface features that could plausibly host the activity. What does this mean for you at the bedside? When you hear that the orbit has been refreshed, you can translate it to, we have more dots, and the curve is thanking us. When you read that small non-gravitational parameters are included, you can translate it to, the comet is doing comet things. If a strong claim appears that turns those ordinary notes into something urgent, you can wait for the next set of measurements without fear. Comet physics is slow enough for sleep. The numbers will still be there in the morning, a little tidier, a little truer to the sky. Set the scale down now. Watch its beam level itself as if warmed metal were finding its rest. The pendulum in the corner ticks a slow, even arc. Our traveller breathes out a little and feels the gentle answer in its course. The ember in the grate glows, not bright, just constant. That is the feeling of non-gravitational acceleration when you whisper it properly. A breath, a balance, and a curve that matches the night more closely than it did before. Let's gather 3 simple baskets and place our questions inside them. First, surface topography. Fixed vents on a turning body can send out narrow streams that our line of sight sums into straighter threads than they truly are. Second, pulsed illumination. If only certain angles receive direct sunlight, jets may fire in brief windows each rotation, leaving spaced filaments that stack into lines. Third, geometry and fields. Dust sheets can present as a sunward needle when we look edge-on, while ions can be trained by the solar wind's magnetic structure into very straight tails. None of these is exotic. All are testable. Across early and mid-November, observers shared sequences where more than one thin feature accompanies the coma. On some nights, a sunward-leaning strand holds from frame to frame. On others, a long away from sun line stretches like thread under tension. Stacked images, comet-aligned, make faint details accumulate. Star-aligned stacks tell a complementary story about what broadens when you privilege the background instead. The recurring theme is persistence. When multiple nights and multiple instruments repeat a structure, the signal deserves a careful vocabulary and a calmer explanation than impulse might offer. Start with the ground beneath the glow. A nucleus is not smooth. Cliffs, pits, and scarps act as nozzles. As the body rotates, day slides across those forms, and gas escaping through narrow throats can launch dust in tighter ribbons than a broad, sunlit patch would. Orientation matters. If a vent points near the sky plane for part of the rotation, its plume's projection can look thin and straight, even while the source turns. Long exposures, then stitched together moments when the ribbon is most visible, and our eyes prefer the stitched line over the softer, curved portions that fall below the threshold. This isn't a trick. It is how faint signals behave when time and rotation are both in play. Pulsed, illumination sounds more dramatic than it is. Imagine a steep-walled pit that sees sunlight only when the sun peaks along one exact bearing. For a short span each cycle the pit wakes, the rest of the time it cools and quiets. With ejection speeds of a few hundred meters per second, material released during each window drifts outward while the nucleus turns toward night again. Over days, those repeating pulses can line up into a train of segments that, under certain viewpoints and contrast stretches, blends into a single thread. If a second pit at another latitude fires with a phase offset, a companion line can appear, and what looks like a pair of straightjets could be two gated vents with different clocks. Now step into the third basket, geometry and fields. Dust and ions part company early. Dust grains, carried by gas, soon fly on their own and feel radiation pressure that sorts them by size, broadening and curving the tail. Ionized gases, by contrast, couple to the solar wind's magnetic field lines. That coupling often draws out a very straight, very narrow ion tail that can remain pencil-thin across enormous distances. To an eye that sees mostly continuum light, the ion line can be faint. To a camera in filters that catch gas emission, the line stands out like ruled ink. If, meanwhile, Earth sits near the comet's orbital plane, the broad dust sheet can project as a sunward needle, the classic anti-tail, despite particles always moving away from the sun. Perspective is the quiet author here. At the edge of detection, reduction choices matter. Comet-aligned stacking preserves the moving subject and smears stars into streaks. Star-aligned stacking keeps the stars sharp and smears the comet. Both are honest, but faint, straight features benefit more from one method than the other, and contrast stretches can elevate the narrow while hiding the diffuse. That is why competent reports show both treatments, list exposure times, and compare different filters. The goal is replication. If a line persists across methods and nights, confidence grows. If it appears in one recipe and vanishes in another, we have a clue about what the feature likely is. What remains to test? Narrowband imaging separates gas emission from reflected sunlight. If a thread brightens in ion-sensitive filters and fades in broad continuum, it leans toward the ion tail class. Polarimetry, which measures how light is polarized by scattering, can distinguish dust-dominated structures from gas-dominated ones. Dust tends to imprint a different polarization signature. Time-resolved sequences tied to the 16-hour rotation can search for spacing that matches a pulsed source. And of course, independent observers, spaced widely in latitude and longitude, provide small parallax shifts that help reconstruct three-dimensional orientation. Each test is patient. None asks the mind to sprint. We also keep a hand on limitations. Ground-seeing blurs. The point spread function of a telescope gives every bright dot small shoulders. If a faint line runs just where those shoulders cancel, it pops from the background more readily. Moonlight raises the floor and hides the vague, while leaving the narrow. Even sky flats and bias frames, if imperfect, can introduce or suppress hairline structures. Seasoned imagers check for all of this. They rotate the frame to rule out fixed pattern noise, inject synthetic lines into control stacks to gauge visibility, and share their raw sums so others can repeat the arithmetic. What about rotation versus line straightness, the part that makes brows furrow? One natural picture is that we're integrating many minutes of emission while the nucleus turns modestly. If the visible thread is ion-dominated and anchored by fields external to the comet, the line will prefer the field's direction rather than the rotating face's momentary aim. Another is that we are compressing depth into a two-dimensional image. A helical path seen end-on looks like a line. Slightly change the viewing angle and the line softens into a lane. Change the filter and it becomes fainter or brighter depending on which species you allow through. None of this excludes surprises. It simply gives geometry and plasma their turn before bolder ideas take the floor. And then there is help arriving from another vantage. A camera orbiting Mars took images when the comet passed far closer to that world than to ours, giving a side-on view of the anti-tail and of whatever narrow features accompany the coma. A release around mid to late November is expected. That perspective, neither Earth's edge-on bias nor a single colour, can settle whether a sunward-looking thread truly points that way in 3 dimensions, or whether we were living in a happy accident of alignment. Side views are kind to questions like these. They also soothe arguments because distance and angle are no longer guesses, they are measured. For a minute, let's leave the formal tests and step into a quiet room where a loom waits. The shuttle moves left, then right, then left again, steady as a calm breath. Threads under tension look like lines, threads without tension fall into gentle curves. The comet's images feel like that cloth in the making, some strands taut and straight, others wider and softer, the pattern readable if you stand at the right distance and let your eyes relax. Hear the soft tap of wood, the whisper of fibre. 30 breaths, nothing to decide, only to notice. We keep the 3 baskets close, shapes on the surface, pulses in the light, and the geometry of dust and fields. We match them to images from many hands, and we let the side-on view tie the threads. If something remains after that, it will deserve a new basket. Until then, we weave, not rush. Before we race, ahead, let's set expectations, the kind that help the mind rest. A camera in orbit around Mars turned for a few precious moments toward our traveller when it passed nearer to that world than to ours. The instrument is famous for seeing boulders and dune ripples on the Martian surface. From millions of kilometers away, its gift will be different. Not pebbles, not craters, but geometry. A side-angle look at the glow and the thin structures that have teased us from Earth. Think of a darkroom tray. You lower a blank sheet into a silver bath and wait as edges emerge. That is what these frames can offer, edges that confirm direction. What can they show, softly and well? First, perspective. From Earth we have mostly watched near the comet's orbital plane. That viewpoint can flatten a broad dust sheet into a needle that seems to point sunward. From Mars, the angle changes. Side on, a sheet looks like a sheet. A thread that is truly narrow remains a thread. If a line's apparent straightness was born of our alignment, the Martian view will relax it into a lane. If it was anchored by plasma in the solar wind, it will still run taut, and we'll see how it leans against the sun's direction. Either way, an ambiguity melts. Second, layering. A single image can't separate dust from gas, but a small sequence through different filters, or companion observations from Earth close in time, lets us compare brightness changes. If the side-angle line brightens where ion-sensitive bands are strongest and fades in broadband continuum, we have a quiet vote for ion tail. If the broadsheet dominates and tints toward sun-yellow reflection, dust is speaking more loudly. Paired with spectra from ground telescopes, even 2 or 3 Mars-side frames function like a stereo listener. 2 ears, 1 song, depth restored. Third, parallax. A feature that hugs the sky plane from one vantage can pull away from it when seen from another planet. Tiny differences in the centerline of the tail, or in the angle between a thin strand and the solar vector, matter. With careful timing, Earth and Mars together act as a 2-point ruler, and modelers can trace a 3-dimensional spine through the coma, instead of guessing its tilt from a single projection. This is not glamorous, it is cartography for light. It is also exactly what images from 2 worlds are good at when the target is too distant for fine surface detail. Let's be clear about limits, because limits make for better sleep. The nucleus will likely be a bright core, not a resolved world. Even a famous high-resolution camera loses its sharpness when a subject is far away. Do not expect cliffs and pits. Expect shapes at the scale of the whole coma, and strong lines that span large fractions of the field. Think of it as weather, not street maps. A swirl, a front, a jetty of brightness crossing a bay. These are the right metaphors for what the data can deliver. The cadence matters too. If the Mars team captured more than one image, timing relative to the comet's 16-hour rotation can hint at pulsing. 2 frames separated by a few hours that show a straight line in the same place argue for a stable feature in space. An ion-trained ray, or a dust plane, not a quick spray from a single vent that rotated away. Frames that change with the beat suggest source regions that wink on and off with local day. Even a small set of images can nudge us toward one picture or the other when paired with our Earth-based light curves. There is another kindness these images can offer: scale. With the camera's plate scale and the comet's distance known, the width of a line measured in pixels becomes a width in kilometers. On Earth, we can be fooled by contrast stretch into thinking a feature is thinner than it is. On Mars, a different instrument with a different response gives us a second opinion. If both agree that the strand stays tight across huge distances, then tight is no longer a feeling, it is a number. And numbers relax debate. Expect, as well, some visual surprises that are normal in off-axis views. A bloom that looked symmetric from Earth may appear lopsided from Mars, not because the comet changed, but because we did. We moved to a new stool in the same gallery. The anti-tail that once seemed to kiss the sun may reveal a small offset. A fainter companion line might stand apart from the main one. These are gifts. They turn pictures into measurements. What will these frames not decide? They won't settle the comet's composition on their own. They won't announce internal power or rule it out. They won't weigh the nucleus and they won't certify cause for any thin line that appears. For that, we still need spectra, polarization studies, and time series that track the 16-hour rhythm. Images are the stage. Other instruments speak the lines. I like to imagine the processing room the week the files arrive. Screens dimmed, coffee left to cool. The first calibrated image opens, and there's the head, a bright seed with a soft halo. The anti-tail lifts like a shallow dune caught in sidelight. A narrow filament holds a straight course farther than a fingertip can trace without lifting. Or perhaps it does not hold. Perhaps from this angle it is plainly a fan, and our earlier needle was a trick of alignment. Either outcome is a kindness. Clarity always is. And because we're speaking for sleep, let's give patients a good chair. The Mars frames will sit beside Earth's best in a long, quiet ledger. Together, they'll let the community update geometry, tune models, and choose next targets for deep spectroscopy as the comet glides past closest approach in mid-December. No countdown is required here. Just a steady hand on the notebooken. A willingness to let perspective do its work. Sidelight is powerful, the way a coastline appears at dawn when the sun is low and every ridge has a shadow. What we need are those low-angle shadows, rendered not as drama, but as lines we can trust. Now let the darkroom door ease shut. Imagine a moon setting behind hills, the silver of its path thinning and then slipping away. The tray sits quiet, the image fixed. We haven't demanded more of it than it can give. We have taken what it is best at, angle, edge, alignment, and folded it into a gentler picture of a traveller crossing our plane. The rest will wait for morning. The rest will be there when you wake. We'll open the window of the night just a little and let the room breathe. Streetlights glaze the wet pavement. The air carries that faint cool of distant rain. A refrigerator gives a small sigh. Then nothing. Somewhere a scooter hum rises and falls like a soft bell. The fan turns a patient circle, washing the ceiling with a slow sweep, lighthouse steady. Count back, not with digits, but with small preparations. Dim the screen, place the phone face down, loosen the jaw, rest the shoulders, lengthen the breath. Outside, the sky holds to its schedule. Our traveller is on the outbound leg, and a gentle milestone waits in mid-December, close for study, far for comfort. A countdown can be a lullaby when every step is ordinary. Professionals are already aligning their lists. Big mirrors will watch for subtle color shifts and faint lines, the kind that tell water and carbon-bearing gases apart. Spectrographs will sip the coma's light and lay it into bands like threads on a loom. Photometers will keep time with the slow rotation, asking if the rhythm remains the same from night to night. Polarimeters will listen for the signature of dust, because scattered sunlight is shaped by particle size and texture in ways that are quiet but clear. Space telescopes, freed from the weather, will take the steadier view, while agile ground instruments fill the timeline with longer watches. The community cadence is simple. One team gathers spectra across a few hours. Another maps brightness in several filters at the same time. A third stacks images from a different latitude, where the tail's angle changes by a breath. These pieces meet on shared tables, and patterns become more than hunch. If an ion-trained strand keeps its course, it should brighten in the right bands while remaining narrow. If a dust plane is giving us a sunward needle, only because we sit near the orbital sheet, then a change in vantage will soften it. Every test is patient. Every answer earns its way by repeating. The mid-December window is kind to listeners too, not because the comet blazes. Few interstellar visitors become backyard spectacles, but because the geometry makes measurement less fussy. The angle to the sun, gentler. The distance, while still safely enormous, is smaller than it was, which means a little more detail for the same exposure, and a little less fight with noise for the same filter. It is like hearing a conversation at the end of a hallway move one doorway closer. You still need to lean in, but you no longer need to guess. What will amateurs do while the big glass hums? They'll give us the night-to-night heartbeat. Small telescopes excel at time. One backyard adds a few hours. Another, farther west, adds a few more. A third, south of both, fills the gap just before dawn. Together, they make a bracelet of points around the globe, catching small changes that major facilities, with tight schedules and shorter observing blocks, might miss. If a filament strengthens near local day on the nucleus, the ensemble will see it. If the rotation nudges a vent into light and back into shade, tiny rises and dips will line up to the comet's slow metronome. You'll hear, during this time, a few familiar words. Spectroscopy night means they're looking for chemical notes. Water's fragments, carbon's families, the glow of molecules stirred by sunlight. Polarimetry run means they're weighing the directions of light waves to learn how dust grains are shaped and aligned. Time series means a promise to sit still and listen long enough to hear the rotation in brightness. None of these asks for drama. They ask for clear air, steady instruments, and people who like to make careful notes. Safety sits quietly beside every plan. The comet passes at a distance that is roomy by any human standard, farther than the warmth of our intuition, close only by the scale of astronomy. No alarms, no special precautions, just observation. If you step outside on one of those nights, you won't see it with the unaided eye. You might, with binoculars, find comfort in recognizing the constellations that frame the region of sky where the traveler wanders, though the traveler itself will remain a whisper in professional glass. Sometimes it's enough to know that something is there, and that thoughtful people are looking, and that their attention is a kind of lantern we can borrow for sleep. What will those people bring back for us to place on the bedside table? Velocities in the jets, slow, medium, or quick, which separates dust-driven fans from ion-driven lines, ratios of gases that sketch where in a natal cloud this material might have formed long ago, confirmations that the rotation keeps steady or shifts a little, which feeds our models of how sunlight nudges a patchwork world, polarization maps that show whether the narrow features carry dust or glow mostly with gas, and simple images, stacked and clean, that let us see with our own eyes why an anti-tail can look like a needle, and why the same needle can become a fan when the angle changes. In the middle of all this, notice how your breathing has taken on the same cadence as the instruments. A slow in-breath, and we call up the ephemeris, the night's coordinates that tell a dome where to point. A slow out-breath, and the first long exposure begins. Another in-breath, and the Guider star settles. another out-breath, and the shutter closes. Repeat, gently. The sky is indifferent to our rhythms, yet it gives us the kindness of being measurable in rhythms all the same. You might keep a tiny ritual for the window of best viewing. Step outside for a few minutes before sleep. Find the quietest patch of sky and let your eyes adapt. Name a star or two, then stop naming and simply look. Consider the length of the path that brought this object here. Consider the ordinariness of what we're doing, splitting light, measuring angles, stacking frames, and how that ordinariness is the strength of it. This is how the universe becomes familiar. Not by revelation, but by patience that folds small truths into a larger one. The lighthouse sweep crosses the ceiling once more. A soft bell of traffic fades to nothing. Before long, the closest pass will have come and gone, and the traveller will be 1 degree smaller, 1 degree dimmer, on its way to the outer dark again. We will be left with notebooks full of gentle facts and a handful of good questions to carry forward. Tonight, we only need to be carried by the sound of rain beginning far away, then nearer, then close, until it becomes a hush that erases edges and turns the world simple. Let it. The window is open just enough. The air is clean. The night keeps watch. Scales help the mind rest. When the weather turns, we glance at a chart with soft lines and colours, and a word like gentle sits over our town. Astronomy borrows that comfort sometimes. When the conversation grows large, natural or not, rare or routine, we draw a small ruler on the margin and say, let's place a mark, not a verdict. A proposed ruler for interstellar visitors runs from 0 to 10. 0 means certainly natural. 10 would mean certainly artificial. The idea is not to decide for all time, but to assign a provisional place that can move as data arrives. Like isobars on a weather map, the mark drifts with new pressure from fresh observations. No court, no gavel. A framework to keep us honest about uncertainty while we fall asleep to the hum of instruments doing their steady work. I like to sketch it as a soft gradient. At the low end, objects behave in ways our catalogues know by heart. A bright coma, a dust tail that curves with radiation pressure, spectra that sing the old songs of water fragments and carbon family lines. Near the middle, something strays from the usual. A push that's hard to match with measured outgassing, a shape that resists easy modelling, a rotation or brightness trend that asks for more than one night's explanation. At the high end, we reserve space for evidence few of us expect to see, persistent, unambiguous signs that technology is present, the kind you can point to with a fingertip on a page and feel your breathing change. Examples calm theory. Years ago, one traveller passed quickly through our sky with a twitch that didn't come with the normal breath of gas. Another arrived later and looked every inch a comet, from colour to composition to the way sunlight lifted materials into a broad, familiar plume. The first sits, in many tellings, somewhere in the ambiguous middle. The second sits low, a helpful anchor that reminds us how ordinary an interstellar comet can be. Neither number was a verdict. Each was an invitation to keep watching without leaning too hard either way. Where does our current visitor live on that gradient tonight? Somewhere that asks for patience. The ledger we've built is mostly ordinary. A coma that glows in the greens of diatomic carbon, radio ears that hear hydroxyl from sunlit water, a slow, comfortable spin written into brightness like a clock that prefers long ticks. Images have also shown thin features in November frames, some sunward-looking, some away, that look straighter than a casual eye expects. A ruler helps hold both truths at once, solid observations in the columns we know how to fill, and a handful of open cells that simply read, measure again. Probability is the language behind the ruler. It moves like weather, too. Day 1. A forecast says, perhaps. Day 4. The models have more data and the word softens or strengthens. In that spirit, a mid-range mark on the scale does not mean 50-50 in any dramatic sense. It means we're living in the interesting middle, where natural explanations are viable and testable, and where a few features deserve extra time under better filters, wider baselines, and kinder geometry. The best thing about that middle is how much good science it summons without asking for certainty first. To keep the ruler honest, we list what would move the mark. Clear changes in thin features correlated with ion-sensitive filters would nudge a line toward the natural family of plasma tail behavior. Repeating spacing in a thread, tied to the 16-hour rotation, would favor pulsed illumination from fixed vents. A side-on view from Mars that relaxes a needle into a fan would push the scale down by making geometry do most of the lifting. Conversely, if multiple instruments document narrow lines that ignore changing viewing angles and remain rigid where ion behavior predicts bending, the mark could drift up a notch while we look harder. No cliffs, only steps. There's a social kindness built into scales when we use them carefully. They let communities speak plainly without sharpening their voices. A spectroscopist can say, "For now, I place this near the middle. Here's the data set that would move me," and a dynamicist can answer, "My number differs by a notch. Here's the model that would change it." The numbers are not armor. They're invitations to trade recipes and plan the next night's efforts so that uncertainty shrinks in the places that matter most. For a bedtime mind, it helps to borrow the weather chart one more time. Picture a map of isobars drawn in soft blue. High pressure is a region of confidence. Low ranks on the scale where observations pile up like smooth stones. Low pressure is a storm of questions. Mid-ranks where drafts tug at the lines, and each new image can sway the curve. Forecasts improve with denser measurements taken at the right places. We do not shout at the clouds, we fly more balloons. In astronomy, a balloon is a run of spectra, a stack of images from two hemispheres, a few quiet hours at a radio dish. You might wonder whether a scale risks turning wonder into a score. It needn't. The act of assigning a provisional number and saying why it is provisional is a way to honor the sky without demanding it hurry. We can tuck the ruler into the notebook's back pocket and return to the images we already have, richer for knowing how we'll change our minds when the right kind of light arrives. That is a gentle discipline, the sort that makes science compatible with rest. As the December window opens, the mark for our traveller can stay penciled, not inked. A little lower if sidelight from Mars reveals fans we mistook for needles. A little higher if coordinated filters show a strand that refuses to behave like gas, dust, or projection. Either shift is an invitation to gather more, not to harden a conclusion. The scale, like a weather chart, is most useful when people keep updating it and keep agreeing that updates are the point. Now let's lower the volume together. Imagine an old television with no signal, the grain of static like fine snow. Your eyes soften. The hiss is steady, and in that steady noise there is comfort, because nothing urgent hides inside it. The ruler we drew is tucked away. The map's isobars fade into grey. Outside, the sky is doing what it does without our labels. We will draw them again in the morning, and we will draw them better because we slept. If a theatre keeps its lights low, you can see both the painted set and the faint outline of the rigging beyond it. That is the right brightness for tonight. Not to choose a side, only to let two pictures share the same quiet stage. First picture, held like a thought experiment. Imagine a long journeying craft that wants to blend into ordinary traffic. It carries volatiles because gas is a useful way to shed heat, to nudge its path, and to keep the disguise consistent with what telescopes expect of a comet. It rotates slowly because a slow wheel is a kind wheel, giving stability and small, predictable forces across its frame. When adjustments are needed, it opens valves that look like vents, and the exhaust draws thin, clean lines that read as jets. Seen from far away, the whole act resembles the familiar story of sunlight warming ice. The stagecraft works because it borrows truths from nature and lets distance do the rest. Now breathe and set the second picture beside the first. Nature alone. A nucleus that is rough and crusted, with pits and ribs that behave as nozzles when local noon arrives. Gas drags dust free. Some dust sheets appear as needles when we watch nearly edge-on across the orbital plane. Ionized gases couple to fields in the solar wind and lay out threads as straight as taut wire. A slow spin writes a steady rhythm in the light curve, while the coma's shape changes gently with geometry. Look long enough, and the straight can soften into a lane, change filters, and one line fades while another grows. In many seasons past, these natural tools have made odd things look simple, without asking for a new kind of actor behind the scrim. The value of letting both pictures breathe together is not suspense. It is discipline. If you listen for design, you write down the tests that would make the listening honest. If you prefer drift, natural structures guided by wind and light, you write down tests as well. Then you run them with patience, because patience is the instrument that makes other instruments matter. What would move the needle toward design? A narrow feature that stays rigid through changing viewpoints and remains bright in filters where ion tails should not dominate. Time series that show a thread hold in fixed orientation in space while the nucleus turns, in a way that cannot be made from pulsed sunlight or helical paths seen end-on. Non-gravitational pushes that persist even as spectroscopic mass loss remains far too low to power them, across independent datasets reduced by different teams. Consistent departures from models that already include the usual comet physics. Outgassing laws with thermal lag, ion tail behavior, dust polarization, and projection effects. In every case, the bar is not mystery. The bar is repeatability that resists the simple answers. What would settle comfortably into drift? A side-on view that relaxes a needle into a fan. Narrowband imaging where the thin line brightens in ion-sensitive bands and fades in continuum. polarization maps that fingerprint dust in the sunward sheet while gas owns the straight array. Rotation-tied spacing that marks gated vents in pits and scarps, the kind of spacing a 16-hour wheel produces when one face wakes and sleeps with local day. Orbit fits that breathe the way comets breathe, stronger terms near the sun, weaker terms outbound, with small asymmetries explained by illumination and surface patchwork. Hold those lists in one hand, and the room's hush in the other. There is no hurry to advance either picture. The mid-December window is kind to this. More spectra, more filters, and a second vantage will arrive and fold into the ledger. If the fine lines truly ignore geometry, the ledger will say so without raised voices. If they reveal themselves as the familiar artistry of plasma and perspective, the ledger will say that, and we will sleep just as well. There is also humility in what images cannot do by themselves. A thin line that keeps its discipline may still be a magnetic story told by ions. A bright core that looks too crisp can be a measure of instrument response rather than a clue to structure. A curve that wanders from an early prediction can be a catalogue's tiny bias rather than a course correction. Good practice is not to banish wonder. It is to put it under light that lets the ordinary speak first. Thought experiments are welcome at bedtime if they are honest about boundaries. In the first picture, a camouflaged craft would make choices that overlap with comet behavior, because that overlap hides it best. Rotation for stability, volatiles for thermal control, exhaust that resembles jets. Such a design would also leave fingerprints that differ from a world of ice and dust, thrust that decouples from sunlight, lines that refuse the expected filters, rhythms that ignore the wheel. If those fingerprints appear and persist, design earns its turn on stage. If they do not, the play remains a comet's play. You don't need a verdict to rest. You need a clean list of what would change the conversation. For some, it is the Mars side geometry. For others, it is line widths and velocities in gas bands that decide whether a bright filament is plasma or dust. For others still, it is polarization maps, or the continued harmony between rotation and color. The sweetest part of this season is that all those threads can be woven at once, and the cloth does not care who wished for which pattern. Let's give the stage a minute of stillness. A velvet curtain breathes from an unseen vent. Ropes settle in their pulleys with a soft wooden tap. Far up near the catwalk, a light fades one click, then another. In the wings, a tray of paintbrushes rests on clean paper. The set on stage looks like a quiet shoreline at night. A gull cries once, and then thinks better of it. The orchestra pit is empty, but a single stand light glows. For 60 seconds, we leave both pictures on their marks and listen to the room. Air in, air out. The scrim is a faint blue. The audience is only us. When the minute ends, we keep the same dim. 2 pictures, both lawful to test, both gentle to hold. If design is present, it will step forward under the same lights that have always served drift. If drift is all we find, it will be the sort of drift that makes a science better by asking it to see more clearly. Either way, the curtain will lower without hurry, and the room will stay kind as the last lamp is covered. I keep a small ledger open beside the bed. The paper is cream, the lines are pale, and the pen moves slowly enough that each word feels earned. On the first page, I write how this traveller appeared, a new point found by survey eyes in early summer, measured against the fixed quilt of stars, until its path proved open-ended and unbound, interstellar, not ours to keep. Space-based optics sketched a teardrop of light in July. The coma tracked as the telescope followed the moving dot and let the background smear. A quiet beginning to a long crossing. Turn the page, and the ledger notes a clock. 16 hours and a little for one full turn, not hurried, not near any edge that would pull a loose body apart. The light curve folded cleanly when many nights were stacked, an agreement that comforts because it means different eyes, under different skies, heard the same rhythm. A slow rotation like a brass wheel in a clockmaker's room, offering stability and a set tempo, against which other changes can be measured. When a curve keeps time, the rest of the picture has a place to lean. Another entry records colour and breath. Near the head, a green that comets often wear, diatomic carbon singing when sunlight nudges electrons and they fall back, band by band. In the radio, a pair of quiet notes where hydroxyl whispers the presence of water broken from ice. Images sometimes showed a tail that seemed missing. The geometry explained that absence as a face-on sheet that hides width behind glare. Other nights, thin lines appeared, one toward the sun by our viewpoint, another narrow lane away, features that patient comparisons treat tenderly with words like ion tail, dust plane, projection. Each is a placeholder for tests, not an answer written in ink. The path gets its own column, drawn as a fine thread across the ecliptic road. Retrograde, yet close to the plane where planets keep house, which is where many of our instruments already look. Perihelion in late autumn, outbound now, and mid-December marked as a comfortably distant closest approach that nonetheless improves the odds for clean spectra, steady timing, and plots that breathe less with weather and more with the comet itself. A note in the margin says that cameras aboard Mars had a side seat earlier in the season, and that a release of those views was expected as November waned. Useful. Not for cliffs and pits, but for angle and edge, the things that turn needles back into fans or confirm a line's tautness in space. On the last page, I draw a thin underline and write only what is steady tonight. A visitor confirmed as interstellar. A slow spin measured in light. Gas that glows in familiar hues and hums in familiar lines. Images that have shown narrow features and anti-tail presentations under viewing geometries we can model. A path through our planetary plane that is good for watching and ordinary for sky mechanics. A season of coordinated eyes, ready to listen for small pushes, to split light with care, to compare filters and angles without haste. Everything else waits in the measure again column. Patient, unafraid of time. There is no cliff at the ledger's edge, only a quiet assertion that the next night will add a line, and the night after that will add another, until the book is gently full. Thank you for keeping watch with me. The room is quiet now, and the ledger we wrote together is a small, steady thing on the table. A visitor from elsewhere crossed our attention this season. We followed gently, the way you follow a lullaby through a doorway and into sleep. What held most firm was simple. The body turns every 16 hours or so, not hurried, not near a breaking edge. Its coma glows with familiar green close to the head, the kind of colour sunlight teases from small molecules. In the radio, water's fragments speak in their own careful way. Images gathered in November showed thin lines and a sunward-looking needle under certain angles. Features we know how to test with filters, perspective, and time. The path threads our planetary plane, retrograde and calm, with a mid-December closest approach, far enough to be comfortable and close enough to help our instruments listen better. Nothing in that list asks you to decide anything grand. It only asks for patience, and you've already practiced that by being here, breath by breath. The teams will keep measuring while you sleep. Spectra in quiet bands, light curves folded over slow hours. Images from two worlds compared like postcards held side by side. When morning comes, the sky will still be tracing its careful curves. Our notebook will still be here, a page ready for the next line. For now, close your eyes. Let the last of the numbers fade to something softer than thought. The fan turns, the house settles. A traveller glides on, and we wish it well. May your night be easy, your dreams untroubled, and your waking light. Good night. Sleep deeply. I'll keep the lamp low. The ledger will wait. The sky will keep watch. End of script.